Hello everyone, welcome to this video lesson. In this video lesson, we would like to explain Einstein's photoelectric equation. We know photoelectric effect is the property of the light because of which when a light of suitable frequency incidents on metal surface, there is emission of electrons from the metal surface. Some observations were made as it is explained in the previous video lesson, like photoelectric effect is instantaneous process and so on. How do we explain that? For that, we have by the time Maxwell's electromagnetic wave theory and Huygens wave theory, which assumes that light like a wave, but that's not helpful in explaining the property of photoelectric effect. So Einstein has taken the Planck's quantum concept into consideration. According to Planck's quantum concept, light is emitted like a quanta having a fixed energy E equal to h nu or hc by lambda. That energy depends obviously on the frequency of the incident light, and they are called also like photons. So Einstein has borrowed the concept of Planck's quantum concept, and he said when a light of particular frequency strikes a metal surface, it has an energy, photon. That photon has an energy of that photon equal to h nu. This energy from a given photon is absorbed by the electron on the metal surface. Then this metal surface needs some energy to release itself from the metal's nucleus. That minimum energy required is called work function. So the given energy of the photon is first of all is used to liberate the electron from the metal surface. That minimum energy required for that liberation is called work function. With the remaining energy of the given photon, the electron starts moving from cathode to anode. Thus, it possesses its kinetic energy. So h nu, that's the incident energy of the given photon, which will be given to only one electron, is equal to work function. That's also an energy which can be expressed as h nu naught, where nu naught is the minimum frequency and h nu naught is the minimum energy to release itself from the metal surface, and kinetic energy half mv square. So what happens? Obviously, why it is instantaneous process? Because photon is obviously moving with velocity of the light. So that property is explained. If the instant frequency is less than that of the minimum frequency called as threshold frequency, the energy given by the photon is less than work function, then the energy of the photon is not sufficient to liberate the electron from the metal surface, then there is no photoelectric effect at all. If nu is equal to nu naught, energy of the photon is just equal to work function, then the electron has no energy to move from cathode to anode, so it stagnates in the device itself. So just emitted, photoelectrons are just emitted. If the incident frequency is more than that of the threshold frequency, then part of the energy is used to liberate the electron from the metal surface. Still, the photon given energy is there with the electron, therefore it starts moving from cathode to that of a anode. Thus it possesses a kinetic energy. Now, if intensity of the light is more, if the intensity of the light is more, it is obvious that the light has more photons. Each photon will go and give the energy and they liberate more electrons. Each photon will give its energy to a given electron. So more electrons are emitted. Thus, if intensity is increased, photoelectric current increases is explained. Of course, the number of the electrons that are available is limited. Soon the saturation will reach where all electrons are, once if the saturation is reached, that is number of available electrons is over. Even if there is more photons, there is no takers, therefore current reaches its maximum. So why with the increase of intensity of the light current increases is explained. Further, the energy of the photon E is h nu depends on frequency but not intensity. So if nu is more, as nu naught is constant, kinetic energy is more. If the kinetic energy is more, the electron starts moving with more kinetic energy towards the anode from the cathode. When we apply reverse potential, what happens? When we apply reverse potential, we are giving an energy E equal to VQ or else a VE, because depending on the potential definition, work done equal W by Q. We are applying this voltage against the kinetic energy of the electron. So what happens when we apply VQ that is equivalent to that of the kinetic energy, then the electrons stop moving from cathode to that of the anode. That's why we call this potential as a stopping potential. So at stopping potential, the reverse energy of the applied voltage is equivalent to the kinetic energy of the moving electron. Thus, we can rewrite the Einstein's photoelectric equation as work function plus energy due to the stopping potential AV naught. So energy is h nu, stopping potential is h nu naught plus AV naught. So h of nu minus nu naught is AV naught. Or even you can also write h of nu minus nu naught is half m v square. So we can write an equation like nu minus nu naught is directly proportional to the square of the ejected electron. Now it's very clear that as nu naught is fixed, nu minus nu naught is directly proportional to V naught. That explains that graph. This is the, say, stopping potential frequency. This is the minimum frequency nu naught. A given frequency nu. This is the stopping potential on the graph that we have drawn in the previous video lesson. That's why nu minus nu naught, this value is directly proportional to the applied voltage. Thus, Einstein photoelectric effect has explained what all the properties that were being observed. Further, if you draw the graph, if you take this equation into consideration, h of nu minus nu naught is EV naught. So h by E is V naught by nu minus nu naught. So if you take the same graph, so if you redraw the graph that we are drawing just for the sake of observation, taking the frequency on x-axis and the stopping potential on y-axis, when the instant frequency is less than the threshold frequency, the energy of the photon is not sufficient to the release of the electron from the metal surface. That's the work function. So there is no photoelectric effect. Once, if you apply a frequency more than the threshold frequency and you start applying the reverse voltage, then photoelectric current will decrease and finally it becomes zero. More the incident frequency, being work function is constant, it possesses more kinetic energy. As it possesses more kinetic energy, we need to apply more reverse potential, thus the stopping potential is more. If you measure the slope of this graph, slope tan theta is, opposite side is V naught, adjacent side is this part, nu minus nu naught. From this equation number 1 and 2, we can say h by E is the slope of the graph. So h is Planck's constant, E is the charge of the electron, that is also constant. Being these two are constant, the slope is constant. So we are able to find Planck's constant using the Einstein's photoelectric equation. Thus it has not only explained the properties of photoelectric effect, but also helped us to find the slope of the graph. This explains why it is same for a different metal also. It's obviously for any metal h by E is constant, therefore the slope is constant. That's it. Thank you for watching. Keep coming back for more and more video lessons. Thank you.